Here's one more example of Hess's law. We are going to calculate the delta H of reaction for this overall equation, P4O10 solid plus 6 PCl5 gas to produce 10 Cl3PO gas. And we're going to do this using Hess's law and the following four equations. Equation number 1 says P4 solid plus 6 Cl2 gas produces 4 PCl3 gas. Delta H for that is negative 1,225.6 kilojoules per mole. Equation number 2 that we're going to have available says P4 solid plus 5 O2 gas produces P4O10 solid. Delta H for that reaction is negative 2,967.3. Equation number 3 says PCl3 gas plus Cl2 gas produces PCl5 gas. Delta H for that is negative 84.2. And last but not least, equation number 4, PCl3 gas plus 1/2 O2 gas produces Cl3PO gas. And that delta H is negative 285.7. So what we're going to do is arrange equations 1 through 4 so that they will add up to the overall equation that's shown here. And again, we're just going to take the overall equation one species at a time, starting with P4O10 solid. We need to find that in equations 1 through 4 and put it on the reactant side. It's not in equation 1. Here we have it in equation 2. It's a product, so we want to reverse this reaction to put it as a reactant, and we can keep the stoichiometry the same because we need one. We've got one here. So we are going to have P4O10 solid produces P4 solid plus 5 O2 gas. And the delta H for that, remember, because we reversed it, the sign of delta H reverses, and it's 2,967.3, not negative. So that's our first reactant. Now we need 6 PCl5 gas reactants. So we're going to look through equations 1 through 4 and find PCl5. And here it is in equation 3 as a product. It needs to be a reactant, and we need to have 6. So we're going to flip this equation backwards, and we're going to multiply the whole entire thing by 6. So we're going to have 6 PCl5 gas to produce 6 PCl3 gas and 6 Cl2 gas. And our delta H, we're going to reverse its sign and multiply it by 6. So it's going to become positive, and it's going to be 6 times 84.2. That takes care of that. Now we need Cl3PO on the product side, total of 10. So we look through equations 1 through 4 to find Cl3PO. And here it is in equation number 4. It's on the right side of the equation, but we need more. We need 10 of them. So we're going to take this equation and its delta H, and we're going to multiply the whole thing by 10. So now we're going to have 10 PCl3 gas and 5 O2 gases, and we're going to produce 10 Cl3PO gases. And our delta H, our equation stayed in the same direction, so the delta H sign is going to stay the same, but the whole thing needs to be multiplied by 10. And that gives us our product. So now we have all of the reactants and products in the right spot. We need to go through this equation before we add everything up and make sure that this equation is adding up the way that we want it to. So let's first see what kind of stuff we can cancel out. We've got 5 O2s on the left side and the right side that we can cancel out. We've got P4 solid that can't be canceled. We've got some PCl3s that can be canceled. We have 6 on the right and 10 on the left, so we can cancel all 6 of those and take that one down to 4. That looks like that's all the cancellation that we're going to be able to do. When we add these equations up together, these three, we get P4O10 solid plus 6 PCl5 gas plus 4 PCl3 gas to produce P4 solid plus 6 Cl2 gas plus 10 Cl3PO gas. And that's not the equation that we're trying to add up to. That doesn't match our original given equation up here. We've got this, which is what we want, and this, and this. But we've got to get these 3 other terms out of there. And in that case, when that happens, just go back to your given equations again and see if you can find an equation that has PCl3. Ideally, we could find one equation that had PCl3, P4, and Cl2 in it. And here it is, PCl3, P4, and Cl2. And it looks like our stoichiometry is even right. 4 PCl3s, 1 P4, 6 Cl2s. So what we want to do is bring in equation 1 and use that to cancel these terms out of this kind of not quite overall equation that we've put in. So we want equation number 1 exactly the way that it's written. If we add that in, I'm going to use that blue again. We're going to add in P4 gas plus 6 Cl2 gas to produce 4 PCl3 gas. And that delta H, just the way the equation is written, because we didn't change it at all, that delta H is negative 1225.6. So again, we're going to cancel again. P4s are going to cancel. 6 Cl2s are going to cancel. 4 PCl3s are going to cancel. And this equation is going to add up, our new overall equation is going to add up to exactly what we want. P4O10 solid plus 6 PL5 gas, PCl5 gas, to produce 10 Cl3PO gas, and the delta H for that reaction is going to be the sum of these delta H's that we used to add the whole thing up. So it's going to be 2,967.3 plus 6 times 84.2 plus 10 times negative 285.7 plus negative 1,225.6, and all of that adds up to negative 610 kilojoules per mole.